Okay, welcome to Monday. Go ahead and get out your homework. So the last, I'm going to get 3 lessons or so. We will use these extensively in the rest of your math classes. So geometry through calculus into college. Being able to simplify square roots, very important. All right, here are the answers. Go ahead and check your work. And then answer question number 1 on the Google Forms. How many you got wrong? Good? Okay. Okay, so let's look at the calendar here. So we're going to do 11:6 today. Notice next Monday's down day off. District 49 wants to take a break before finals start. So we're going to do all of Chapter 11. Chapter 11 ends at 11.8. Now, I had the option of doing a Chapter 11 test or trying to squeeze in a couple of the lessons from Chapter 12, the only chapter we're not going to fully cover this year. So that's what I'm going to do. 12.3 and 12.4 are pretty darn important for Algebra 1. There's probably, I guess, maybe 2 concepts that I will not be able to cover this year. I mean, Chapter 12 is bigger than that, but I'm saying 2 large concepts that you're supposed to cover in Algebra 1 that I will not be covering. Well, I guess, good news, bad news, bad news, I can't cover it. The good news is that it will be covered again in Algebra 2, and I'm confident that it won't affect you greatly, and it certainly will not affect you next year in geometry. Everything that you need to be successful at geometry, I have covered or will cover. There might be, I don't know, very, very, very few questions on the PSAT test. And I don't even think there will be a single one that I will not have covered. There's one concept called complete the square that I will not cover. And my hope is next year with a full year that, before you have to take the PSAT test, that I'll cover it in geometry class and just tack it on to the geometry curriculum. So that's how we're going to roll. So notice there at the very end, that third week there, we start finals. So I'm going to do 2 days of a semester final review. We'll review the chapters that we covered from all the way from January until now. As always, I'll give you a perfect copy of what the semester final will be. You'll have good study material, and if you can pass the test review or the semester final review, you'll be fine on the final. The one caveat to all that is that the finals week start on that third week on Friday. So on that Friday, you'll take your English final. That's going to be a 3-day weekend because Monday is a holiday. That Monday, that one you're not seeing here, that Monday is a holiday, and then Tuesday, Wednesday, Thursday, Friday, you'll have one final every single day. Every single day there will be a final. So Tuesday, Wednesday, Thursday, Friday. The math final will be on Thursday. So here's how this works. You're going to have the semester final review this third week. And then the following week on Thursday is when your math final. So there's going to be a lot of days in between when we do the semester final review and the test. And that's going to go for all your classes. I know that all teachers will be doing semester final reviews. But there will be a significant lag between those final reviews and the actual test. It's not going to be the final review the day before, except for the English final, obviously. If you have any questions on what those finals week, when we get into next week on next Wednesday, when I pull up the calendar, you'll be able to see the full testing schedule. But if you have any specific questions on, hey, I need to know when I'll go ahead and tell you. So let's see, it goes English, history is on Friday, math is on Thursday, and then you have science. I believe science is on a Tuesday, and what subject am I skipping? Oh, yeah, Latin would be on a Wednesday. So that's how that is going to work. Make sense? Okay. Here's your homework for this lesson. Oh, boy. Good news and good news. So the good news is it's Pythagorean theorem, yay. The other good news, no bad news, it's a direct copy of last year's class. I mean, there's nothing new. This is just strictly a review of what you've already previously learned about the Pythagorean theorem. Okay? All right, so hopefully you remember this. And by the way, I'll just tell you point blank that this is the same slides that you saw last year. So let's talk about the Pythagorean theorem. It's one of the main applications using square roots that we'll see. Well, it's called the Pythagorean theorem. So the word theorem, if you remember from last year, just means a mathematical rule. Next year, in geometry, your entire world will revolve around these things called math theorems in geometry. The entire book of geometry is nothing but math theorems. Theorems are what tell you what you can do in math. And this is called the Pythagorean theorem. Pythagorean theorem comes from the person who wrote it down. We're actually not 100% sure if he actually came up with it. One of his students came up with it, but he is credited with this theorem simply because his school was the first to write this down. So the first record of a written record of the Pythagorean theorem was written by the school that he worked at, and it was Pythagoras' school, so he gets credit. So he was a Greek philosopher, mathematician. There is a statue of him. And his theorem or his math rule revolves around right triangles. So it must be a right triangle. Pythagorean theorem only applies to right triangles, not any other type of triangle. It's got to be a right triangle. All right, so a little bit of background information on Pythagorean theorem. First off, the parts of a right triangle. So the parts of a right triangle, please write this down. The parts of a right triangle, draw a right triangle. We know it's a right triangle because the little square there, the square at that angle indicates that it's a 90-degree angle, a right angle. The two sides of the triangle that form the 90-degree angle are called the legs. So the legs are the sides that form the 90-degree angle. They touch that little square, okay? The opposite side, or the side that is opposite the right angle, so that little dotted line is just indicating the side that is opposite the right angle, is called the hypotenuse. So the hypotenuse is the opposite side to the right angle. Okay? All right. From last year, probably the hardest thing when you're first doing this is to understand which side is the hypotenuse. It's critical to use the Pythagorean theorem. So here are three right triangles. I flipped them, I rotated them. Just remember, all right triangles have two parts. They have the legs and they have the hypotenuse. For me, I always identify the hypotenuse first. So on that blue triangle right there, I find the right angle. I look to the side opposite. So that dotted line is not part of or dotted arrow is not part of the right triangle. It's just indicating where the hypotenuse would be. Okay, and you will not see that dotted arrow on most right triangles. The other two sides are called the legs. Now, there's no differentiation between the two legs. Typically, one is smaller, one is shorter. And remember, you can have an isosceles right triangle and where the legs are exactly the same distance. Okay, so how about the red one? So once again, I always find the hypotenuse first. That is the side that is opposite the right angle, called the hypotenuse. And then the other two sides are their legs. And then on the yellow one, the side that's opposite the right triangle, or the right angle, is the hypotenuse. And the other two sides are your legs. Make sense? Okay. So back to the Pythagorean theorem. Remember that the side that is opposite the right angle is the hypotenuse. Here's what Pythagoras said. He said, well, hypotenuse is a very long word, so let's name it C instead. And we'll name the legs A and B. So he said, if you have a right triangle with legs A and B and hypotenuse C, that the following is true. That if you square both of the legs and then add them together, that will equal the square of the hypotenuse. So this is where the famous a squared plus b squared equals c squared. One quick note, c must be the hypotenuse. A and B can be any one of the legs. It doesn't mean that A has to be the short leg and B the long leg. Either one is fine. It doesn't matter. But the legs have to be A and B. The hypotenuse have to be C. So that's the Pythagorean theorem. Please write that down. Okay. Oh my. All right. Maybe put another note there that says that C is always, 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 always the hypotenuse. So this is the Pythagorean theorem in text form. If you have a right triangles with legs of A and B and C as the hypotenuse, then A squared plus B squared equals C squared. Next year in geometry, I will not teach you anything that I cannot prove to you. Right? You will learn next year what proving means. This year and all your previous years of math, the math teacher gets up, they say, listen to me, this is true, write this down, now do the work. Okay. Next year, that will not happen. I will not say anything to you that I cannot prove, at least math-wise. I will not say anything to you that I cannot prove. But for this year, unfortunately, you're going to have to just accept the fact that this is true. Next year, you'll be very familiar with this picture right here. This is one of the many different ways to prove that a squared plus b squared equals c squared. It looks awfully complicated. So how about we leave this for next year? Okay, I will give you this is not a proof, but this is a demonstration of the Pythagorean theorem. So remember, it says the square of the two legs added together is equal to the square of the hypotenuse. Well, just remember what the word square means. Square literally means, well, it's something to the second power, but it also means a square. Imagine a triangle where squares touch the three sides. In other words, there are three squares that touch the sides of a triangle. Now imagine the areas of those three squares. The areas of those three squares would be a squared, b squared, and c squared. So what are you seeing right here? Well, you have a triangle. Each side of the triangle makes a square. And then what the Pythagorean theorem says is that if you square the two legs and add them together, that will equal to the square of the hypotenuse. And that's what this video is showing you, is that the two areas of the legs, that would be a squared and b squared, or side squared plus side squared, that equals the third, or the hypotenuse side squared. Now, mathematicians would laugh at this video right here because this is not proof, but this is certainly a good demonstration of it. We'll learn about proofs next year. All right, so once again, remember this is just simply a repeat of the class that you had last year. So how does this work? You will be given a right triangle with two sides. You have to calculate the third side. Step number one, identify the hypotenuse. Always make that your first step. So where's the hypotenuse on this triangle? Well, remember, that's the side that is opposite the right angle, so it's not listed. But we do know that the side that's opposite the right angle is called the hypotenuse. Pythagoras called it C. Well, if that side is C, that means side 3 and 4 are your A's and your B's. Now we simply use a little bit of algebra to find the answer. So I know that A or B is 3 or 4. You get to pick which one, and it doesn't matter which is which. However, C is the unknown, and Pythagoras said you need to square C. So I square 3, I square 4, I add those sums together, or I add those values together, and that will equal to the C value squared. That's the Pythagorean theorem. A squared plus B squared equals C squared. Make sense? Now it's just an algebra problem. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. Notice it doesn't say C equals 25. It says C squared equals 25. Hey, this is from last night's homework. How do you get rid of squaring? You do the inverse operation, square root. Okay? Take the square root of both sides. The square root of C squared, it's even, right? Therefore, you take half of it. That would be C. And the square root of 25. The principal square root would be 5. And this kind of illustrates why we don't use the plus or minus in real-world problems, because it wouldn't make any sense for C to be the value -5. That means its length would be -5, which is why we use the principal square root. By the way, next year, we will entirely just use the principal square root. Okay, let's do another one. All right, so let's see. I said that step number 1 is to always identify the hypotenuse. So the hypotenuse is opposite the right angle. Now remember, that dotted arrow right there is not part of the triangle. It's just showing you where the hypotenuse is. The hypotenuse, it doesn't have a value, therefore it is C. And we plug those values, the two legs of 5 and 6, and the hypotenuse of C, into the Pythagorean theorem. We square all three sides. So A squared, I'll just make it 5. B squared, I will make that the 6 value, and C squared obviously is the unknown. All right, let's see. 5 squared is 25, 6 squared is 36. 25 and 36 are 61. We have a problem when we try to take the square root. Let's see. Any perfect squares go into 61. Can we simplify that? No, we can't. Therefore, this is a calculator problem. The square root of 61. Let's round to the nearest tenth tonight for homework. Is about 7.8. Notice I put the approximation symbol. If there are units involved, we would put units. But in this case, there's no units. Making sense? You want to try one? All right, let's do this one. So let's see. I said step number 1 is find the hypotenuse. That's the side that's opposite the right angle. That's C. A and B are 6 and 8. We throw those three values, 6, 8, and C, into the Pythagorean theorem. 6 squared is 36. 8 squared is 64. 36 and 64 is 100. And the square root of 100 is 10. Make sense? All right, go ahead and do these two all by yourself, and then answer question number 2 on the Google Forms. How'd you do? Good? All right, let's see. So the first one, let's see, we're missing C value. 3 squared plus 4 squared equals C squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. The square root of 25 is 5, so that C has to equal 5. Second one, we're missing the C value. So let's see, 12 squared plus 5 squared equals C squared. 12 squared is 144. 5 squared is 25. 144 and 25 is 169. The square root of 169 is 13. There you go. So what's your big problem with all this? Yeah, we've only solved for the hypotenuse. What happens if we know the hypotenuse and we're missing one of the legs? Well, let's see how that works. Well, I said step number 1 is always to find the hypotenuse. Well, the hypotenuse now is 13. So therefore, that means that we're missing A or B. Take your pick. It doesn't matter which one. I will call that bottom one, I'll call it B. If you wanted to call that A, that would work as well too. All right, so let's see. Now we have our A, B, and C. Let's plug the values in. A is 12, B is B, and C is 13. 12 squared is 144. 13 squared is 169. Okay, so now algebraically, what do? We're not going to take the square root. Just like last night's homework, we're going to subtract 144 first. 169 minus 144 is 25. Yes, I'm using the same problem over and over again. The square root of 25 is 5. Make sense? All right, let's do one. So, step number 1, identify the hypotenuse. Hey, the hypotenuse is 26. Okay, so I'm missing A or B. This time I'll say I'm missing A. Throw A, 10, and 26 into your formula. 10 squared is 100. 26 squared, I'm grabbing my calculator. It's 676. Subtract 100 from both sides. Do you recognize 576 as a square root? It was one of those perfect squares, right? Probably not, because I only had you memorize the first 16 perfect squares, and the square root of 576 is 24. Okay? Yes, you may use your calculator. All right. This is the next one. This is question 3 on the Google Forms. Do these two, please. All right, here we go. Jackie, what you get? First one. What was that? Well, let's see. We're missing A or B. A squared plus 8 squared equals 10 squared. 10 squared is 100. 8 squared is 64. 100 minus 64 is 36. The square root of 36, she is correct. It is 6. All right. Next one. What we got? Sierra, what do you got? Yeah, this one's a bit more challenging. So we're missing A or B. It doesn't really matter which one. I'll call it A again. So bottom line, you were correct that the final answer is 24. We good? Okay. One last thing, right? You may or may not remember doing this last year. They're going to give you 3 values. Now, any 3 values may form a triangle. It's not guaranteed. Not all 3 measurements can form a triangle. Certain ones do. And then further, certain ones of those that actually do form a triangle can form a right triangle. So what I'm saying is I'm going to give you 3 numbers and say, can you take those 3 distances, those 3 values, and make a right triangle out of it? Maybe you can make a triangle, but is it a right triangle? Well, this is one of those applications of the Pythagorean theorem. So the Pythagorean theorem says that if it is a right triangle, then a squared plus b squared equals c squared. Look at all the previous ones. What do you notice about the hypotenuse in relationship to the other two sides? Is it smaller or is it bigger? Well, hopefully you notice on all the examples that the hypotenuse is the longest side. Now, I will explain that next year in geometry why that's so, but for right now, you just need to remember that the hypotenuse is always the longest side. So, to figure out if three measurements can make a right triangle, we just use the Pythagorean theorem. So, step number one is we write the base Pythagorean theorem. That just means the Pythagorean theorem without any numbers plugged into it, okay? Step number two, if the and it's true, the longest side is the hypotenuse for right triangles, well then what's the longest side here? Well, the longest side here is 5. So we're going to make 5 the C value, and the other two values the A and the B value. So once again, if it's a right triangle, the hypotenuse is the longest side. I'll prove that to you next year. And then the other two sides must be a and b. And we know that if it is a right triangle, that a squared plus b squared must equal c squared. Now, it could be a triangle, just not a right triangle. But if it's a right triangle, a squared plus b squared will equal c squared. So now all we do is see if this is true. 3 squared is 9, 4 squared is 16, and 5 squared is 25. So step 3 is we evaluate or we do the math. And 9 plus 16 is in fact 25. So step number 4 is if you see the left side of the equation actually equals the right side of the equation, that is true. Okay, therefore, yes, that's a right triangle. Let's see another one of those. Okay, there are the 4 steps. Is it a right triangle? Now, it can be a triangle without it being right. We'll see that next year. But this technique basically says find the longest side. Because if it's a right triangle, then the longest side will be the hypotenuse. It will be the C value. Well, the longest side here is 20. So we're going to make that the C value, and the other two sides the A and the B. And it doesn't matter which one you pick, A and B. We okay? Now we simply do the math. 12 squared, 144, 10 squared, 100, and 20 squared, 400. Does 144 plus 100, well, you can see that right there that can't be true, right? So even though those 3 sides, maybe it makes a triangle, maybe it doesn't, but it certainly does not make a right triangle. All right, so go ahead and do these 2. Remember, the longest side is your hypotenuse. Do the math and see if the left side equals the right side. And this is the last question on the Google Forms. And it's a yes or no question, by the way. How'd you do? All right, let's see. So on the first one, the one on the left there, the long side is 15. So 9 squared plus 12 squared equals 15 squared. It turns out that both sides equal 225. So yes, that is a right triangle. And using the math teacher principle, the second one must obviously be Landon. All right, Landon says, well, if the first one's yes, then the second one must be no for math teachers. And generally that's true. Let's see if it's true. Let's see, the biggest side there is 20, so that's your C value. So it's 15 squared plus 12 squared equal 20 squared. 20 squared is 400, and the left side equals 369. So that one is a big fat no. We okay? All right, if you struggled on any of this, please let me know. But I'm just going to point out this was the same class that you had last year. So hopefully you kind of remember this. All right, so those are the 3 objectives that we did today. That's your homework. Have a good Monday, and I will see you guys on Wednesday. You remember that from last year? Okay.